The main objective is to identify the pharmaceutical industry, which is involved in the research, development, production, and marketing of medications for both human and animal health, an essential part of healthcare systems around the globe. Like other chemical sectors, the pharmaceutical industry faces numerous environmental challenges. The scientific formulation, investigation, and development of medications, that is, those useful in the prevention of treatment of disease and disorders, forms the foundation of the pharmaceutical industry. Various chemicals including corrosive and irritant agents like acids, base, oxidizing and reducing agents, solvents, and many more are used in the manufacturing of APIs and formulation process.
Next, you are going to introduction of the pharmaceutical industry. The pharmaceutical industry, involving public and commercial organizations, develop drugs and remedies through primary and secondary processing of chemical ingredients. Challenges include regulatory information, therapeutic targets, and research methodologies. Next, the issue of the pharmaceutical industry. The pharmaceutical industry is developing target therapies like ATMPs to address challenges like flammable materials, hazardous chemicals, and UV radiation, requiring smaller regional manufacturing units and reliable investment planning models. Next, you are going to problem statement. This study examines the impact of treatments and manufacturing processes and supply chain networks in the pharmaceutical industry. It reviews literature and discusses recent steps to support decision making. The paper reviews hazard identification, turf inspection, and discusses the pharmaceutical industry's innovation in this area. Next, we are going to objectives. First is, we want to study the effects of hazard factors that can lead to health issues of worker and the community. Second, to analyze the impact of pharmaceutical waste that affect the environment. Third, to propose suitable corrective action to reduce the risk or eliminate hazard. Next, we are going to significance. This study will redound the employer risk-free from accidents and injuries by taking action to maintain a safe working environment in the pharmaceutical industry. By deepening our understanding, we aim to safeguard the health and well-being of workers and prioritize long-term environmental protection. Ultimately, the study aims to contribute to a reduction in workplace accidents through the identification and implementation of effective control measures.
Next, we go through the definition of pharmaceutical industry. The pharmaceutical industry is an industry sector involved in the research in medicine that discovers, develops, produces and manufactures drugs and medication with the aim to cure and prevent disease or alleviate various medical conditions and disease. This industry plays a crucial role in discovering and manufacturing medicine. Next is the process of pharmaceutical industry. The process of pharmaceutical industry is the process of drug manufacturing and can be broken down into a range of unit operations such as blending, granulation, milling, coating, cable pressing, filling, and others. The pharmaceutical manufacturing process has precise requirements and manufacturing guidelines for quality. Pharmaceutical process development is from research and develop laboratory formulation to commercial production of pharmaceuticals. The pharmaceutical manufacturing process is typically made up of a combination of specific unit processes chosen according to physical and chemical properties of the active pharmaceutical ingredients. There is 7 processes of pharmaceutical industry. First one is powder blending, which is a wide range of excipients may be blended to create the final blend. Next is dry granulation, which is the compaction of low density powder to a granule. Next, we have micronization, the process of reducing the particle size of pharmaceutical products. Next, the next process is drying, which is to control the moisture content of powders. We also have pharmaceutical milling, which is the process of using rotary cutters in pharmaceutical equipment machinery. Other than that, high shear and wet granulation, which is the processes of gasification to improve flowability. Also, we have compression of powder or granules into tablets, which is an efficient process for producing a solid dose medication. Last but not least, pharmaceutical encapsulation, which is the containment of a solid or liquid dose.
So next, I will explain about occupational safety and health in pharmaceutical industry, physical hazard in pharmaceutical industry. So first, physical hazard is excessive noise. Excessive noise in pharmaceutical industry can arise from various sources, including machinery, equipment, and processes involved in drug manufacturing and packaging. This noise can have several implications for both the health and safety of workers and the overall efficiency of operations. So number one, health impact. Prolonged exposure to high level of noise can lead to occupational hearing loss. The pharmaceutical industry often involves the use of machinery such as compressors, grinders, mixers, and packaging equipment, which can generate significant noise. Without proper hearing protection, employees may experience hearing damage over time. So, second is safety concerns. So excessive noise can interfere with communication, making it challenging for workers to convey important information or warnings. In an environment where precaution is crucial, such as pharmaceutical manufacturing, distraction caused by loud noise can contribute to accidents and errors. This can compromise both the safety of workers and the quality of pharmaceutical products. Some common machines in the pharmaceutical industry that produce noise is granulators and mills, mixer and blenders, tablet press machines, compressors, HVAC system, packaging machinery. Them are able to generate a high level of noise that can give disastrous consequences for the surrounding specific with detrimental effects on the health and well-being of employees.
So next about chemical exposure. So active pharmaceutical ingredients, which is APIs, is an active ingredient in medication that cause the desired therapeutic effect, and it may come into contact with workers during the production, handling, and packaging process. So first about organic solvent. Organic solvent exposure has been associated to reproductive toxicity, which include negative effects or fertility, fetal development, and pregnancy outcome. Adverse pregnancy result is miscarriage, which is some research have suggested that exposure to organic solvent may increase the chance of miscarriage. So next about birth abnormalities, which is pregnancy. Exposure to certain solvent may increase the risk of birth abnormalities in developing fetus. So next, low birth weight. Occupational exposure to organic solvents has also been linked to an increased chance of having a low birth weight baby. So last, harmful mechanism. Organic solvent may interfere with the hormonal balance required for a successful pregnancy, perhaps leading to difficulties. Some solvent may have direct harmful effect on the developing fetus, affecting organ development. Next, about estrogen exposure. So number one, endocrine disruption, which is estrogen is endocrine disruptor, and exposure to elevated levels may interfere with the normal functioning of the endocrine system. This disruption can lead to hormonal imbalances affecting the regulation of various bodily functions. So two, reproductive health issues.
So estrogen exposure is associated with reproductive health effect in both men and women. Exposure to high level of estrogen may disturb fertility, menstrual cycle, and sperm production. For pregnant women, exposure to estrogenic substances may pose risk to fetal development. So 3. Cancer risk. Prolonged exposure to estrogen has been linked to an increased risk of certain cancer, including breast and uterine cancer. Workers with significant and prolonged exposure may face a higher risk of developing this type of cancer. So number 4, menstrual irregularities. Female workers may experience disruption in their menstrual cycles due to estrogen exposure. This can manifest as irregular period of change in menstrual flow. So number 5, breast health concerns. Estrogen exposure is associated with the development and maintenance of breast tissue. Prolonged exposure or exposure to high level may contribute to breast health issues, including an increased risk of breast cancer. So physical hazard for number 3 is dust and particulate matter. Hand scoping powder causes the most dust during tablet pressing when compared to other action we assess. So while handling and moving particles, the primary cause of dust exposure is when powdered medicines are handled and transferred. This can occur at any point during the manufacturing process, from weighing and mixing to packing and packaging. When powder appeared, transported between containers or process, dust can become airborne. So acute and chronic exposure to respirable particles has been associated to negative health outcomes such as cardiovascular disease, respiratory disease, developmental and reproductive impact, and lung cancer. So physical hazard for number 4 is vibration. Vibration in the pharmaceutical business can be produced by a variety of variables, and it is critical to detect and solve these issues in order to assure optimal equipment operation and product quality. The following are some of the most common causes of vibration in the pharmaceutical sector. Number 1, imbalances in rotating equipment such as centrifuges, blenders, and mills can cause vibration. This imbalance might be caused by uneven product distribution inside the machine, misalignment or spinning elements, or component wear and tear. So 2, vibration can be caused by improper ventilation and airflow system design or maintenance. Unbalanced airflow, turbulence, or fan imbalances can all contribute to this. So number 3, inadequate lubrication of moving parts in equipment can cause friction and vibration. Regular lubrication and maintenance are required to avoid this problem. So last, number 4, vibration in pumps, compressors, and other machinery can be caused by misalignment or rotational shaft and connection. Misalignment can develop as a result of poor installation, wear and tear, or structural change over time. So one major source of concern is hand-arm vibration syndrome, which is HAVS. So which affect workers who use handled or hand guide power instruments. Workers in the context of mixing and blending equipment may suffer hand-arms vibration as a result of the frequent usage of control, adjustment, or equipment handling. HAVS can cause symptoms such as numbness, tingling, and decreased dexterity in the hands and fingers, affecting workers' general well-being and productivity. So last physical hazard is temperature extremes. Heat stress. For number 1, extremely high ambient temperature. It means heat is produced as a byproduct in some pharmaceutical production procedures. Furthermore, equipment such as ovens, autoclaves, and dryers can contribute to increased temperature in manufacturing environments. So number 2, humidity levels. High humidity can increase the effect of heat stress by impairing the body's capacity to cool itself through perspiration. Pharmaceutical production methods, particularly those using water or steam, can contribute to high levels of humidity. So, last, personal protective equipment, which is PPE. Workers in the pharmaceutical industry may be required to wear protection clothing such as coveralls, gloves, and respiratory protection. While necessary for safety, such as clothing can restrict heat dissipation and contribute to heat stress. Heat stress is a hazard, especially in circumstances where workers must wear encapsulating or impermeable PPE. Elevated body temperature can be caused by a combination of the ambient temperature, heat generated by manufacturing operation, and the insulation provided by PPE. Heat-related disorders such as dehydration, heat exhaustion, and even heat stroke can result from prolonged exposure to heat stress. This is especially important in pharmaceutical production regions where procedures generate a lot of heat and in facilities that don't have enough ventilation. So next, about cold stress. Workers who are required to enter and work in cold storage area such as work in freezers or refrigerators may be exposed to low temperature for extended periods. So pharmaceuticals items such as vaccine, biologic, and some pharmaceutical are extremely sensitive to temperature change. Improper storage temperature can cause degradation, loss of potency, and even injury to patient. So pharmaceutical cold rooms are purpose-built settings that keep pharmaceutical at controlled temperature, often ranging from 2 degrees Celsius to 8 degrees Celsius for refrigerated pharmaceutical, as low as -20 degrees Celsius to -70 degrees Celsius for defrozen storage. These tightly controlled settings ensure that drug remain safe and effective throughout the duration of their shelf life.
Next, we want to explain about effect of pharmaceutical industry. 3.4.1 Effect of pharmaceutical industry to human. The exposure of medications and personal hygiene products to human is influenced by various factors, including drug pharmacokinetics, concentrations, and bioaccumulation. PPCPs have been found in water bodies worldwide, but no studies have shown direct health impacts. Long-term exposure to certain chemicals may still have negative effects. Studies focus on determining if medications level are above the recommended daily intake. Concerns have been raised about antibiotic resistance, with some researchers suggesting selective pressure and gene expression effects at sub-inhibitory concentrations. 3.4.2 Effects of pharmaceutical industry to environmental. Persistent pesticides, PPCPs, pose a significant environmental threat due to their unpredictable behavior when combined with other chemicals or concentrated in the food chain. Some PPCPs are found in soil and move up the food chain due to slow acting or unbiological breakdown. research on hormone contaminations in daily waste disposal is ongoing, and PPCP's contamination negatively impacts marine ecosystem, other habitats, and rainbow trout exposed to treated sewage effluents.
We move to methodology. First, we present a clear explanation of the document's objective and purpose. We also define its scope, which includes the procedures, goods, and activities that are included in our review. Information about the risks associated with pharmaceutical has been provided, including information on hazard identification, risk exposure, worker and environmental risks. Next step is to search the literature for this information by visiting multiple research websites and finding data that is applicable to the focus of the research. In order to compile data and references that are consistent with the current industry best practice, we search the content of existing research, guidelines, and pertinent publications. After that, we leveraging the database of Google Books, ResearchGate, and ScienceDirect to find any journal publication published. We also search for relevant publications and journals using the keywords chemical hazard, industrial hazard, organic solvent, hazardous gases, organic synthesis, management of hazard, regulations for chemical hazard, regulatory agencies for hazard, workplace safety, threshold limit value in order to get the best results. Allow me to show you the necessary higher action before I go into the explanation of the Harriet table. To begin with the lowest risk, the description is low when the risk is between 1 to 4. The risk is then considered medium when it is between 5 to 12 and high when it is between 15 to 25 and calls for quick action to control the hazard. The result that we get from this activity are first, manufacturing process, which the process of the making of articles on a large scale using machine in industrial production. The hazard that we observe is mechanical hazard that can cause a serious lesion. The risks are 15 and it shows that it is a serious hazard that need to be avoided by using PPE. Second, handling raw material exposes one to physical hazard, which might cause cuts and injuries. 10 hazards show that this is a medium risk that should be avoided by conduct rigorous quality control on raw materials. Third, operating equipment poses a noise exposure that could result to hearing damage. 16 risks indicate that this is a major hazard that should be avoided by wearing personal hearing protection (PHP) as needed. Employees handling packaging and labeling are susceptible to human error, which could result in incorrect information being labeled. They must therefore perform the quality control inspection. It is suggested that staff get training in order to avoid this. And lastly, distributing the medicine puts the worker at danger of temperature-sensitive products, such as explosion because of chemical reaction with high temperatures. Based on risk 12 that we observe, it is recommended to implement a transportation that can control the temperature in order to mitigate this medium risk.
So this is hierarchy control that we need to organize in the pharmaceutical industry. First is engineering control. Engineering controls typically reduce exposure at the source stage by isolating the procedure within pipes or tanks or by using local exhaust ventilation. It is crucial to prevent uncontrolled release, and this can be done by implementing techniques like quantity reduction and segregation. Second, administrative control. Higher level controls will typically need to be supplemented with administrative controls. Equipment upkeep and employee and manager training on equipment operation are examples of administrative control. Uncontrolled emissions can be avoided in large part by doing preventive maintenance. To guarantee that engineering controls operate as intended, work procedures including any safe handling protocols and unique storage guidelines may need to be created. So the third one is personal protective equipment. Workers may need to wear PPE to minimize exposure to chemicals absorbed through perspiration or contact with skin or eyes. Choosing the right PPE requires specialized knowledge and considering chemical absorption, penetrations, and degradation. Wearing resistant footwear is necessary in certain situations. Improperly sized or purely maintained PPE can also contribute to chemical exposure.
For our recommendations, identify and communicate the most clinically relevant drug adverse event data as part of a comprehensive safety profile. Avoid use of overly general text descriptions for adverse events, including in abstracts. Use statistical analysis for clinically relevant adverse events where appropriate, and disclosure of institutional and investigator industry relationships to research subjects. In conclusion, advancements in technology and increased understanding of diseases have fueled the development of novel therapies and medicines, transforming healthcare outcomes globally. Collaborations between pharmaceutical companies, academia, and government entities have accelerated the pace of discoveries and breakthrough.